Okay, so now we're ready for question number 9 here. All right, in America's Got Talent video, Professor Splash, he jumped from a tower 40 feet high. How many meters is 40 feet? Uh-oh, you got to do that calculation again. Gosh dang, killing you. If the force equals mass times acceleration, okay, so force equals mass times acceleration. Let's take that. If Professor Slash has a mass of 90 kilograms, and I'm assuming he's probably about a 200-pound guy, what is the force on his body pulling him down? The acceleration is the acceleration due to gravity. So, good old, what's his weight? What's his weight? And that's the acceleration he's going to be going down when he goes down. So you might be going, I still don't get it. Okay, that's fine. But here's what we're saying. In question 10, if F equals ma, and his mass is 90 kilograms, and his acceleration is 9.8 meters per second squared, what's the force that's pulling him down? Now I think I get a little bit crazy with it. What is Professor Slash kinetic energy when he hits the water? Oh, remember when we did that calculation earlier? It's on page 1 of your notes. You can follow through with it. In other words, you got to find the height is 40 feet. Is 40 feet, but you got to convert that to meters. So that's kind of the tricky part. And then you have the V is equal to the square root of 2GH. And we got that, we derived that. We did a fancy derivation of that on the first page of the notes there. So what's the next one? What is his speed upon it? Oh, what's his kinetic energy? 11? I just answered 12. I'm sorry. I was getting ahead of myself. This is the answer to 12. 11 is his kinetic energy is 1/2 mv squared. They should have been flip-flopped. But it really doesn't matter. It really doesn't matter. 11, you can answer it this way because what I was actually doing was, what's his force times his distance? That'll equal his kinetic energy, too. It's the same thing. The force you figured out in problem 10 times the distance that he fell times d, which you figured out in problem 11. That'll equal his kinetic energy also. Okay, so you can do problem 10 times whatever you get here for his height. His height, not his mass. Okay? What else we got? Okay, I'm going to stop here and we'll finish the next 3 questions because they might take a little more explanation. And it'll be too long. I've figured out I got to keep these